Hi, my name is Ryan Westbury and I'm part of the Collier Science Department for the district office, and I'm here to show you a couple things about the Labquest 2 and how to go through some probes and how to use them. So let's check them out. So the first thing you see when you turn on the Labquest 2 is you'll see the home screen. I'm going to do a couple orientation things with you so you better understand it. This is the home button. This is a touch screen, and if I hit the home button I can see a lot of different things. Now these should already be connected to the Wi-Fi, which is in connections here, and you can see the little Wi-Fi symbol at the bottom. There are some things you can do in preferences, like changing the light or the orientation. Now I usually lock these when I set them up to be horizontal going this way, because if they're not, every time you turn it, just like a smartphone, it'll just keep rotating around, and students end up rotating and rotating and rotating until all probes are all tangled up. So this is the most convenient way to lock it, which is this direction, and you can change it if you really want to. If you like the vertical method, some people do like that better because of the way the graphing and some of the data shows up, but that's more of an advanced feature. So this is the way they come set up, but just so you know, you can change it or you can adjust it if you'd like to. Another thing is in the system. If ever you have trouble with the screen calibration, you can hopefully get back to this point. If it's just you go to touch it and it's just not working, hopefully the students don't find this and accidentally mess with the calibration, because if you don't hit it right on the square, it's going to end up a little bit wonky. Also, I like to set the date and time to be accurate. This one is not accurate. It is not 5:30. So that's, and then the last thing is if you have your own school Labquest, this is where you would find out what version you're at. The latest version is 2.7 as of September 28th, 2016. So this one is updated. So that's the basics there. As you go through these menus here at the top, as we get to let's say we want to use a sensor. Now each one of these has a little pen. I'm going to probably use that. So I don't have anything plugged in yet, but there is something we can do. We can actually use the internal temperature sensor, okay? And I'm going to go ahead and turn that on right now. And right now the internal temperature is 20.9, and this is accurate to a degree if you take it outside. And we can see a single point of temperature right now, as you just changed. And if we plugged in a temperature sensor, we would also see this. Now this screen is something you can use for single point data collection, which is different from what we're going to say is a graph. Now if I hit the little play button down here, I get a graph. Just get in there. There we go. So now we're going to graph temperature with time. And we can see that little line start to form. And even as it's forming, if you want to change that, we can go to Analyze, Graph, Auto Scale once, and this is going to change as the temperature changes. Okay. So if we had a temperature probe in some heating water that might be changing states of matter from ice water to boiling water or something like that, we would be able to watch that temperature rise up on the graph. If you're not trying to show temperature over time, the simplest and easiest thing is to just use the first screen. And you can do this with a lot of things. Like right here, I've got a relative humidity sensor. I can plug that in, and we'll get the relative humidity here in a second. But just to show you the simplest function here is using temperature and using what I call the home screen for a single point data collection. What you would have students do would be to, if they were using a stopwatch, they could write down the temperature every so often. Or if you're doing if you're going around either the classroom or in the field collecting multiple samples, you could stick the probe in. I tell them to pretty much count to 30, and then at 30 seconds record the temperature of the soil, or record the temperature of you know, the pumpkin, or record the temperature of their hand after 30 seconds. You know, whatever it is, just give it 30 seconds and it gives them something to do, and they can watch the temperature change, and then whatever it says at that time, write it down. But again, if you want to use the graph, this is that section there. Now, let's say I want to store this. I just hit the little filing cabinet. Boom, stored. Now that's stored in run 1, and I can go back and view run 1, or I can go to run 2, and I can do a whole nother graph, and I can do that. I can hit that button there. I can also hit this button right here. This button right here will start and stop. And you want to make sure your students are aware if they are doing something over time, they accidentally hit this, it is going to stop that graph right there. Okay. Other things you can do in this page here is we can tag it, which gives us something to look at. So it's the fastest way to find certain data points. Another way to do that is, I'm losing it here, statistics, temperature. Okay, now we can look at our minimum, maximum. We can change runs. We can go back to run 1, and we can do analyze, statistics, temperature. Now wherever we put this is better than tag. Sorry, forget the whole tag thing. We can see our minimum and maximum and our average for the whole thing. Most classes avoid standard deviation or, you know, delta y, delta x. That's more algebraic than we need for most of our stuff. But if you want to get fancy, you can always do a curve fit, which shows choose fit linear, and that gives us a straight line. So if you ever wanted to really show them a slope, if you want to bring in some math, I know this is an upper level thing, but that's there in case you wanted to show that, or in case you've had that experience and you want to see if your students can do that as well. Just showing you the level 4. This is an extension. And so the next thing we can look at here as we go across the top bar is our actual data table. So you can show students the time and the temperature at each of those times. If you're doing a more extensive lab, you would see that, you know, temperature over time is going to be a lot longer than this. This is literally 44 seconds of data. This is time. It's taking temperature every 4 seconds, which is a lot. And a lot, you wouldn't have them copy that down. That'd be ridiculous. But you can see how a data table and a graph are related, because they do have a hard time matching the two up. As a matter of fact, I have a good activity for that if you're ever interested. Here's a journal section. Sorry, the lab instructions. And then the last part is the notes. So if you were going to have them save this file, you could put in notes. This is kind of clunky. It does take some time to get used to. And then you can do done. And then if you go all the way back to file, then you can save this lab as a temp lab. Or you could put, and then their name. Okay. And then students could put their name in there, and then they would hit save, and then their lab would be saved there forever and ever right here. And then you can just plug in a USB right here, and you can save it. You would go to save it again, and then you'll be able to transfer that to a computer if you wanted to print or view that lab, if it was just extra fantastic. Okay, so that's just some basic. Gonna go through how to do a data collection, and now I'm gonna plug in a probe. All right, I don't even have to do much else except take it out of the bag. I can undo this or not, and then just find the plug. It's gonna fit right there, bingo. And okay. File, quit. There you go. I needed to quit that one because I had saved the file. It doesn't want me to mess up that file. So once you start to save something, it is, and if I hadn't started to save something, it was going to tell me to, do I want to overwrite this data or discard it? And then I would say discard, and then it'd be done. So all I did was plug it in. It's it's going to automatically recognize it, and we can watch the relative humidity of this room change. Generally speaking, these probes don't take very long to get to understand what they're supposed to be doing, so to speak. So only things like the CO2 or the O2 sensors have to take some time to sort of self-calibrate. They take a couple minutes to, you might say, to warm up. Sometimes conductivity or dissolved oxygen or pH also takes a little bit of time to warm up. Most of the ones that just do air or light or force or temperature, they just plug right in and they start going. So we can see relative humidity. So if I was to take samples, this comes pre-set up to sample for 86,400 seconds. That's a really long time. Okay, so all we have to do to change that is, so go back. I'm just going to tap the duration part, and I'm just going to change this to 2 and then minutes. Okay, and the way this comes set up, you would have to actually do that every single time you plug in the probe. It doesn't just stay there. So so again, I got it set to 2 minutes. If I record the relative humidity in here, I can watch this graph go. I do like to actually watch the graph, so I click graph, auto scale, and then it'll start making that graph. Okay, so that's the relative humidity probe, and great for going outside. I know some teachers who will take this and have students either stick it out of the window and collect a couple minutes of data so they can see what it looks like, or actually go on a little data collection to their school common area outside and do some data collection, then come back to the classroom and report on this when they do their weather units, or just about anything. You can do this multiple times a year. The more practice they get, the better. So this graph is really not changing very much. I guess I needed to change the sample rate. Oh, it's doing 0.10 samples a minute. I think I may have made a mistake here. Sorry about that. We're going to make this 120, and then we're going to change that to seconds so that we actually get a second sample. So 10.1. Forgive me for that one there. A little bit of a oopsie, so we can get some more samples. So we need to watch the graph go, but there it is. It's going to go, and I'm going to blow on it. Here we go. Get some humidity out of my breath. Uh-oh, it's melting the tip. Just kidding. All right, so all I did was just blow on it there just to show you a change in the graph, and to show the humidity difference between breath and this is going to start to go back down as soon as it catches back up with the room humidity. So that's the relative humidity. All right. Relative humidity. Okay, moving right along. Now watch this. Even though I hit the filing cabinet, when I unplug this, it's gonna be like, no, don't unplug me. I'm gonna plug in the anemometer, which is the wind meter. Yep, so here's the discard data. I'm just going to discard it. All right, so notice it comes right up. This is the anemometer, and I'm going to go ahead and give it a little blow. All right, so that's fun. So it's set to automatically go for a minute, and I'm going to just if you ever have a really excitable class, they can really just knock themselves out by trying to make this thing go up. I'm going to show you, if I flip it around, it doesn't matter which way it goes. I'm blowing from the back side now. And there's the front side. I flip it around, so it doesn't matter. So whether I blow this side or this side, there it is. So if I hit stop, because I'm just done with collecting data at 30, it's going to just automatically scale it, which is nice. And then if we go to analyze, we can also see some of those things in statistics, speed, and then it gives us our maximum and minimum. So this would be a really good thing to use if you were outside and you didn't want to have them trying to read the whole graph and try and, where does this line up? And you can just tap it. It'll show you. If you just tap it on there. Where does that line up? And then I'll show you at 8.8 seconds. It was 5.2. So wherever I move this to, that changes over here. So just so you know, if I tap that one, that's going to give me the time, 12.2 seconds, and the speed is 1.3. So you can just tap, and it'll just show you and change you. Or you can do this, the analyze, statistics, speed, and you can get all this stuff, minimum, maximum, and average. Okay. So that's some quick data analysis with the anemometer. And I'm going to go back to the home screen. Now this would not be something that would be possible to just do a single point, because you can't read this number as fast as this thing is changing. Okay, it's just changing too fast. So this would be something you would have to graph, and then so if you're outside on a windy day, you want to collect, like, you would collect the full minute. You collect the full minute, and then you would do that analyze statistics, and you would get that average. You would get that speed for a whole minute. So you would have the wind speed, because recording the wind speed for just 10 o'clock on a Tuesday, it could have gusted to 10, but the average could only be 4. So the mean again is the average. So that's the way you would look at this stuff for the anemometer here. Okay. Yeah. So I'm just trying to see if there's anything else you're going to need. All right. So that's it for the anemometer. Now I'm going to show you the barometer. Pretty easy, plug and play. I'm just going to discard it. This automatically comes up as the standard unit is kPa, which is kilopascals, which is convertible. I forget if this one, if I can change, yeah, I can change. So I can change the units. Now all I did to do that was just tap that part. Some of these you never want to zero, okay? Most of them. And make sure your students know that, to never hit 0, because if you zero it, it's actually gonna mess it up. Okay. This is the pressure of this room. If I had opened this up in the mountains of Colorado, I would be getting a different reading right off the bat, because I'm in a different pressure place, so to speak, on Earth. But I can change units to millimeters of mercury. This might be something more standard for what you might be doing if you were doing like, and I've done this before, which is do like a hurricane study. So if we were to suddenly get a hurricane and you wanted to take the probes home and measure some stuff, which I've done, is really fun, and I encourage you to do, or students to measure some of their own hurricane data. I mean, imagine if you could get safely to a place where you could measure the wind, or the pressure drop. Pressure of a hurricane is pretty cool. So this is set up to go for 3,600 seconds. What is that, 6 minutes? So if we let this thing go, and it's going to just record the pressure over time. Now another thing you can do is, if you know a cold front is coming, you can actually plug this thing in, plug the Labquest in, and you can change the sample rate back here. I'm just going to stop you. So let's say you wanted to record the pressure change for a whole weekend. You can actually do that here. You can just go to duration and change the time to, so it would have to be hours. So let's just say it was, so we were doing 3 days and then hours. So that'd be 0.1 samples per hour and 10 hours sample rate based. Okay, so time based. There we go. And then you could actually set this, and you could put in a temperature probe. And if you had a safe place to keep the Labquest near your classroom, and you could stick the probes out the window if you felt like they weren't going to get too wet, you could actually run this for a whole weekend, and then you would come back and you would see a 3-day graph of the whole weekend. And this is where you change this stuff, is back in here. So again, that's, just change duration. You have to think in terms of, usually seconds or hours, and then that's what you can do if you want to do long term, because pressure, honestly, a barometer is only going to change over a long period of time. Like right now, it's just going to keep jumping around between 66, 64, and that could even change when the air conditioner turns off in this room. It's going to change to something, lower probably, or higher. I'm not even sure. I don't know if this is a positive AC or negative AC. So anyway, just to show you that right there. Again, so to change the units, I just clicked it, and then we could change it to PSI if we wanted to. Can change it to ATMs. So we're at sea level, so we're just above 1 ATM. And I don't know, inches of mercury. Any other units that you want to do for the pressure, you can change right there. If you want to compare to anything that you found in the news, you can see if the news is different from the pressure inches of mercury here. That's all convertible right there. All right, and again, this might be something you do over a longer period of time. So again, if you make this graph, this is set up for 6 minutes. You probably want to do that for, let's say you want to do it for a whole weekend. You could do it for, 72 hours. Again, that's how you do it, just 72 hours, okay, done. I just changed the time. It's going to collect temperature for 3 days. I mean, not temperature, pressure, okay? As long as the Labquest is plugged into power, it'll record all that data. And then you can export that, or you can show it to your students, and they can see the change in pressure in mercury over the course of a weekend that a cold front or a warm front came through, and then you can relay that back to your classroom lesson. All right, and that's it for pressure. All right, so here are some of the other features that are in the Labquest 2. And again, I'm going to go back to home. These are in accessories. There's a handy dandy stopwatch, so you can do some stopwatch recording. If you don't want to get out your other stopwatches, it's right there in the Labquest. Easy to do. Another thing is a sound recorder. I'm not sure what you might use that for. Students might play with this more than use it, but they could actually record something, like if they were going to do a recording of their explanation of a lab, they could record this like I'm recording this right now. I could stop it, hit the filing cabinet, I could save it, and then I'd be able to use that later if I wanted to. The camera app is pretty cool. If you just plug in a USB webcam, you can actually use microscope cam if it has a USB attachment, and that's pretty cool. We have one of those available for checkout in case you want to use that, and of course the calculator, easy peasy right there. And audio function, you will know if a student ever finds this because you'll hear some annoying noise like that. The only really redeeming quality for this is to find cancellation, where if you change the hertz, there's node cancellation between left and right. So if you unlink those and we mess with those enough, we can actually get a cancellation But we're not really doing that right now, but that's what you can do with it. Other things in here, there's a periodic table, but you're probably not going to use that. If you did want to look up anything about, let's say arsenic, just random click there. All of the periodic table information is in here, so it's pretty cool for those upper level classes if you wanted to look up the properties of helium and have those at your fingertips. They're right there. Very nice feature there. I think that's about it for the extra stuff. Yeah, accessories, system, we've already been through that. Yep, that's it. So just let me know if you have any questions, or you can go online to vernier.com. Thanks.